Hello everyone. Today I am going to present my project on machine learning regression project on the topic TED Talk View Prediction. So about this project, TED is an unprofitable organization that posts videos online in free. TED is devoted to spreading powerful ideas on just about any topic. These datasets contain over 4,000 plus TED Talks including transcripts in many languages. It was basically started as a conference in 1984 that was designed by Richard Saul Wurman, but due to some reason it was unsuccessful. After 6 years in 1990, it was back with a bang. In TED, speakers shared their views and ideas to the society in 18 minutes. As of 2015, TED and its sister TEDx chapter have published more than 2000 talks for free consumption by the masses, and its speaker list boasts of the likes of Al Gore, Jimmy Wales, Shah Rukh Khan, and Bill Gates. The slogan of TED is ideas worth spreading. So this is the GitHub link for my project. Then moving further, in this project, I aim to build a predictive model which could help in predicting the views of the videos uploaded on TEDx website. Then let's begin. So these are the important libraries that I'll be using for my project. So I have imported all these libraries. Then for the date time, for importing date time, I have used these libraries. And then moving further, first of all, we'll start with connecting my Google Colab notebook to my Google Drive. And then I have given my data set the name DF, and with the help of .read CSV I have loaded my data set. So this is the first view of my data set, which from here we can see that there are total 4005 rows and 19 columns, which are the 19 columns names are talk ID, title, speaker 1, all speakers, occupation, about speakers, views, recorded date, published dates, and so on. And with the help of the head function, I have loaded the first we can see the first 5 rows of my data set, and then similarly with the help of the tail function we can see the last 5 rows of our data set. Then as we know that there are total 405 number of rows and 19 columns in our data set. Then to check the type of data and to check the non-null values in our dataset, we have used .info function. So from here we can see that the talk ID has no null value and its data type is int, and the title has the object data type, the views has int data type with no null value. Then again duration is also int type and has no null values, but some columns are there which have some null values, which are occupation, about speakers. There are some missing values in this. Then to check for the duplicate values, I have uses .duplicated .values count. So from here we can see that we don't have any duplicate value in our data set. Then to check for the missing value or the null values, like how many missing values are there in our data set, we have used .isNull.sum function. So from here we can see occupation has 522 null values, and about speakers also have 503 null values. Recorded date has 1 null value, and the comments column has 655 null values. Moving further, we can visualize this with the help of sns.heatmap. So from here we can see that occupation has null values, and so does comment have some null values. So from the above data processing, we can say that views column is the dependent variable, rest of them are feature columns. There are few values missing from the features like occupation, about speaker, and comments. Most of the features variable are categorical. Then to see what are the columns named in our data set, we have used .columns method. So from here we can see that the columns name are talk ID, title, speaker 1, all speaker, occupation, about speakers, views, recorded date, published date, event, native language, available language, comments, duration, topics, and so on. Then to describe my data set, I have used .describe function. Then from here we can see that there are 405 count of the talk ID, and for the title it is also 405. Then moving further to the variable description, from here we can see that the talk ID column, it tells us about the talk identification number provided by TED. Then title represents the title of the talk. Then speaker 1 represents the first speaker of the TED speaker list. Then all speakers represents speakers in the talk. Then occupation represents the occupation of the speakers, and about speakers tell the verb about each speaker. Then recorded date tells the date the talk was recorded, and the published date, it represents the date the talk was published on TED.com. Then event represents event or medium in which the TED was given. Then the native language, it represents the language in the talk was given in. And then there is we have the target variable as views, which tells us about the count of the views. Then to check for the number of unique values in our data set, I have used nUnique function in all of the columns. So from here we can see that talk ID has 405 unique values. So it means like all of the values are unique. Then title is also unique in each row. Then moving further, we'll do some data wrangling, that is some data cleaning for further processing. So first of all, we make the copy of our original data set, so that any changes made to the original data set does not any changes done on further does not affect our original data set. Then we'll change the we'll fill the null values in the comment section with comment column with 0, and then we'll drop only the NaN values in the recorded date. Then dropping the NaN null values in all speakers column. Then changing the null values of occupation column to Na, and then changing the null values of about speakers to Na. Then we'll make a new column with the name total languages. So from here we'll make the new column as total languages. Then we'll see if there are any null values left. So from with the help of isNA.sum function, we can see that we are left with no null values, and there are no duplicate values left as well. Then the TED Talk DF column contains the talk ID, title, speaker 1, and the total languages column that we have also made. So there are some numerical and some categorical columns in our data set. So we have separated both the columns, different type of columns into data numerical variable and data categorical. So in the data numerical variable, we have the columns as views, duration, comments, and talk ID. And the categorical data we have title, speaker 1, all speaker, occupation, about speakers, native language, available language, topics, related talks, URL, description, and transcript. Then we have made two new columns in our data set by the name recorded date and published date. And then we have extracted the date, month, year for published date and adding to the data set. So from here we have extracted the month from published date column, and then we have again extracted date from published data column. Then we are extracting year from published data column. Then we for published date, again we are extracting weekdays, then converting days of week to days: 1 for Monday, 2 for Tuesday, 3 for Wednesday, 4 for Thursday, 5 for Friday, and 6 for Saturday, and 0 for Sunday. Then we are calculating the video age with respect to days by adding 1 day to the last data value. So from here we can see the new columns that we have made, that are total languages, published month, published day, published year, day of week, day of week number, video age, day. So moving further, we are now creating a new column by the name of average daily views, which is daily views divided by the video age day. So from here we can see that we have successfully made the new column, that is average daily views. Then moving further, in the above the manipulation that I did are, first I started by categorizing variable types. The data categorical variable contains all the categorical columns, and then the data numerical, it consists of all the numerical data types, all the numerical type of columns. Then the views, which is my target variable. Then I changed the dates from object to date time format. Then I created a daily average views feature. Then moving further, we'll do the analysis, data analysis with the help of data visualization. So moving further, my chart 1, it represents the numerical feature of TED Talk dataset. So all the numerical columns that we have, we'll make a visualization of those. So from here, for duration, then for comments, and for views and talk ID, we can see that all of these are rightly skewed columns. Then the chart 2 represents the speaker with the highest views. So we are extracting the records of top 10 most viewed speakers. So from here, with the help of this bar chart, we can clearly see that Alex Gendler is the speaker with the highest number of views, which is followed by Sir Ken Robinson. So from this chart, the insight that we made is Alex Gendler has most number of views, followed by Sir Ken Robinson. Then chart 3 represents the most viewed title and speaker. So we are visualizing this with the help of the bar chart. So from here we can say that Sir Ken Robinson's talk on "Do School Kill Creativity" is the most popular TED Talk of all time, with with more than 65 million views. It is closely followed by Amy Cuddy talk on "Your Body Language May Shape Who You Are," with more than 57 million views. Then moving to chart 4, which shows the most popular event in TED Talks. So the most popular event in the TED Talk is TED Ed, and we can visualize it with the help of the bar chart. So from here we can see that TED Ed is the most successful event on TED, and which is followed by the TED Talk of TED 25 and TED 2014. Then chart 5 represents the top 10 most frequent speakers occupation. So with the help of this bar chart, we can see that majority of the speaker work as writers, followed by journalists and entrepreneurs. Then chart 6 represents the frequency with which videos are uploaded throughout the year. So with the help of this line plot, we can see that the quantity of videos were gradually increasing every year. It went maximum on 2019, but it suddenly dropped in 2020 due to pandemic, and the majority of the videos were uploaded in 2018 and 2019. Then chart 7 represents the during which day most videos are released. So with the help of this bar chart, we can see that we can clearly see that most of the TED Talks are released on non-weekend days. Most of the TED Talks are released on Tuesday and Thursday, followed by Friday. Then moving further to chart 8, which represents during which days videos are watched most. So with the help of this bar chart, we can say that the TED Talks on non-weekend day. This is not on non weekend days, that is on Friday and Tuesday, are most viewed because of the reason that most of the TED Talks are released in non-weekend days, and Friday and Tuesday have the most views, followed by Wednesday. Then chart 9 represents during which month most of the videos are released. So with the help of this bar chart, we can say that on an average, the number of talks released in the month of April, March, followed by February are higher. The number of talks released in August and December are comparatively lower than other months. Then for chart 9, it represents during which month videos are watched most. So in the month of March, we can see that August, November, December month seems to have less views, while March and April months have most number of views. Then moving further to chart 11, which represents during which year most videos are released and what are its view counts. So with the help of this bar chart, we can see that the year 2019 has the maximum number of videos, and same that year 2019 has maximum number of views. So according to the first bar graph, more TED Talks were published in 2019 and 2018, followed by in 2012. The second bar graph shows that there were more views in 2019 and 2018 and less views in 2006, 2007 and 2020. Then this is the correlation heat map, which shows that comment and views are very much collinear to each other, and video age video age and the published year are not at all correlated to each other. Then we make the pair plot for our whole data set. Moving further to feature selection, we'll do some feature selection now. So these are all the columns that now we have in our data set, but we'll be removing some of the unwanted columns. So the columns that we'll be removing are talk ID, title, speaker 1, recorded date, published date, about speaker, total language, event, URL description, and so on. So now we are left with the columns are views, comments, duration, published month, published date, published year, day of week, day of week number, video age day, average daily views, speaker 1, average views. So now there is not much collinearity between the features. So let's try to treat outliers. So now we'll be treating our outliers. So from here it is clear that columns, comments, duration, days of weeks, numbers, video, age day, average daily views, speaker 1, average views have outliers. So let's treat them. So we are replacing the outliers with the IQR values. Then we condition to change the outliers to lower limits and the upper limit values. So now again we'll check the outliers. So from here we can see we are left with none of the outliers. So now we'll be separating our dependent variable and the independent variable. So as we already said that our view is the dependent variable, so we'll be putting it under the name of y variable, and the rest of the features except for view in the x variable. So my x variable contains the columns as comments, duration, published month, published days, published year, day of week, and so on. As we can see, the column published month, published day, published year, day of week number, and video age day have little impact on further analysis, so we'll be removing them as well. So now we are dropping all the above mentioned columns. So now we'll check for the multi-collinearity with the help of variance inflection factor, which is a measure of amount of multi-collinearity in regression analysis. So from here we can see that all the values of VIF are below 10. So we are good to go. Now let's check the multicollinearity now. Multicollinearity is the occurrence of high intercorrelation among two or more independent variables in a multiple regression model. So from here, with the help of this heat map, we can see that there is less collinearity between each column now. So now we'll check the shape. It is 4004 and 4 columns left. So now we'll do the model implementation. So we'll be predicting our values with the help of these models. So the models that we are preferring are linear regression, lasso regression, ridge regression, elastic net regularization, random forest regression, gradient boosting regressor, and XGB regression. Now we'll split our data into test and train models. Then we'll be doing the first model that we are doing is linear regression. So linear regression is a model consisting of a predictor variable and a dependent variable that are related linear to each other. So we'll be putting our train values into the linear regression model. Then to check what is the best fit, we have calculated the right model or not. We'll be seeing these with the help of these mean absolute error, mean squared error, then root mean squared error, and the R squared model, and then adjusted R square model. So from here we can see that the mean absolute error tells about the absolute difference between the predicted minus the actual value divided by the total number of values. Then mean squared error is the square of the predicted minus the actual value divided by the total number of values. Then the root mean squared error tells the is the square root of the sum of predicted minus the actual values square divided by the number of values. Then the R squared, which is also called coefficient of determination. So it is the 1 minus the model upon the baseline. So the value of the R square is always between 0 to 1. So whatever the value is of the mean squared error, and so on, but the value of R square always comes between 0 and 1. Then the adjusted R square is nothing but similar to R square but an improvement to it. So we'll be calculating all the values for these errors, because these tell the best fit lines for our model. Then we'll be doing the lasso regular, like we have got the values for our linear regression. Then we'll be doing the lasso regularization. So basically regularization is done on highly complex model, which means low bias and high variance. So in this method of constraining and regularizing, the size of the coefficient is shrink towards 0. So in lasso regularization, it adds penalty equivalent to the absolute value of magnitude of the coefficient. So first we'll be setting the tuning parameters, and then we'll be fitting the X train and the training set using lasso. And then we'll be fitting the model and then predicting the value of the test and train and test data. Then we'll be again checking the value of the mean absolute error, mean squared error, roots mean squared error, and coefficient of determination, and adjusted R square. So we have got all these values for our lasso regularization. Then we'll be moving further to ridge regularization. So the ridge regularization is the adds a penalty equivalent to the square of the magnitude of the coefficient. So again we'll be tuning the parameters for our ridge regularization, and then fitting our train data set using ridge. Then we'll be checking for the best parameter in the ridge regression. Then again we'll be predicting the values of train and test data, and then again checking all those value which are mean absolute error, mean squared error, root mean square, r square, and adjusted r squares value. So then we'll move further to the elastic net regularization. So basically elastic net regularization is a combination of both lasso and ridge regularization. So from here we are setting the tuning parameters in the elastic net. Then we are fitting the X train and Y train using elastic regressors. Then moving further, we are predicting the values of the train and test data. Then again checking the values of the errors of mean absolute, mean squared error, root mean squared error, coefficient of determination, then adjusted r square. So from here we can see that we have got these values of the mean absolute mean absolute error, mean squared error, the value of the r square, and the adjusted r square. Then all of the evaluation metrics of elastic net regularization have now been calculated. So we'll proceed to random forest regressor. So for the random forest regressor, the random forest regressor is a method used to reduce variance and achieve better accuracy. Random forest can handle large data set and maintain and find missing data and find the missing data in our data set. So again we'll be following all those similar steps for the random forest regressor, which are fitting the X train and the Y train to our fit model. Then again checking the values of the error of mean absolute error, and then mean squared error, then checking the root mean squared error, and then checking the value of the r square of the test data, and then checking the value of the adjusted r square of the data. So now we'll be doing the hyperparameter tuning in the random forest regressor. So hyperparameter tuning is done basically the hyperparameter tuning is like settings of an algorithm that can be adjusted to optimize the performance. So which means that the hyperparameter tuning is done to optimize the performance of our original random forest regressor. So now we'll be doing this all the same steps for our hyperparameter tuning, and then again checking the value for mean absolute error, mean squared error, and so on. So from here we can see that we have reduced the value of r square, which is 85 and 0.85 and 83, and reduced the value of adjusted r square also, which initially was 0.98 and 0.87 and 0.87. So we have optimized our random forest regressor. Then we'll be doing the gradient boost regressor. So basically a gradient boosting regressor is a model. It builds the model in a stage-wise fashion like other boosting methods do, and it generalizes them by allowing optimization of an arbitrary differentiable loss. So we'll create a dictionary of estimator, learning rate, and maximum depth, then fitting the model fitting them to the model, then predicting the values of train and test data, and then checking for all the values of the error of mean absolute error, then checking for the value of mean squared error, and then checking the value for root mean squared error, which is 2,40,527 for the train data set, and checking the value of r square, which is 0.95, and for the test and for the train, and for the test it is 0.90. The adjusted r square value is 0.90. Then at last we'll be doing the xg boost regressor. So this xg boost regressor, it stands for extreme gradient boosting. It reduces the overfitting in a model. It do the parallel processing, which makes it faster. It also helps in handling the missing data. So we'll be setting the learning rate and n estimator and maximum depth. Then we'll fit the object to train data set. Then finding the optimal model with respect to best estimator. Then we'll be predicting the values of train and test data. Then checking for the value of mean absolute error, r squared, adjusted r square, root mean squared error, and so on. Now, to see which of the feature is the most important with the help of the XGB XGB regressor, we see that the speaker one is the most important feature of our data set. So even more than the comments, duration and views, the speaker one is the most important feature. So all of the evaluation metrics for XGB regressor have now been calculated. Now we'll combine all of the results to find the best model. So here we are combining all the models, which are linear, lasso, ridge regression, elastic net, random forest, gradient boost and XGB regression. So from here we are making this, giving this as the name ML models. Then we are we are making it a data frame by the name of conclusion data frame. Then we'll print the data frame. So from here, so from my above processing, I will conclude these points, that the EDA conclusion are Alex Gandler is the most popular and has the most views. With over 65 million views, Sir Ken Robinson's talk, Do School Skill Creativity, is the most popular TED Talk of all time. The most popular TED Talk event is TED Ed, followed by TED 2015 and 2014. The majority of the speakers are writers, journalists, and business owners. The majority of TED Talk are released during weeks. The most views are on Fridays and Tuesdays, followed by Wednesday. Then, for the model conclusion, I would like to say that since mean squared error and root mean squared error penalizes outliers very much, we will use mean absolute error as evaluation matrix. For train and test mean absolute error, random forest regression and gradient boost produces relatively good results. XGB regression is on the other hand produces unsatisfactory results, since there is significant difference between the train and the test mean absolute error. Even though random forests give us good train mean squared error results, the test error is pretty high. Similarly, XGB regression and gradient boost regression shows overfitting issues. The data set root mean squared error is not recommended, as we can see there is problem of underfitting. For this data set, R square produce the best result for each regression method. There is no overfitting as shown by the adjusted R square results. According to previous finding, random forest regression produces the best result for each evaluation metric. Most important feature is found to be speaker one average view. That means views on the TED Talk majorly depends on the speaker, and more popular speaker gets more the views. Thank you so much.